In today's tutorial, I'm going to show you how to use math tables to improve your performance in addition, subtraction, multiplication, and division. See the link in the description for the downloadable PDF that contains the math tables I will be using in this tutorial, as well as some blank templates for you to create your own math tables for practice. When we do math practice, we usually get a handout that looks something like what you see on the screen. So let's go ahead and do the math for this set of problems adding 2's, and then we'll do the same thing using a math table so you can see the difference between the two types of math practice. So I have 2 plus 1, which is 3, 2 plus 2 is 4, 2 plus 3 is 5, 2 plus 4 is 6, 2 plus 5 is 7, 2 plus 6 is 8, 2 plus 7 is 9, 2 plus 8 is 10, 9 plus 2 is 11, 10 plus 2 is 12, 11 plus 2 is 13, 12 plus 2 is 14. Now let's do the same thing, but this time we're going to do our addition using a math table. And the way that a math table works is you have numbers written on the left and numbers written on the bottom, and the operator that you're going to use is in the corner. So we're going to take this number 2, then we're going to add it to the number on the left. So my first problem I have is 2 plus 0, and that equals 2. So where these two numbers intersect, that's where I'm going to put my answer. Now my next one is 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. 2 plus 4 is 6. 2 plus 5 is 7. 2 plus 6 is 8. 2 plus 7 is 9. 2 plus 8 is 10. 2 plus 9 is 11. 2 plus 10 is 12. 2 plus 11 is 13, and 2 plus 12 is 14. So you'll notice we just went through and did the exact same thing that we did on the worksheet, but by having them on the table, we can already notice that when we're doing addition, everything just increases by 1. So if I get stuck on a problem, I can just start wherever I stopped, wherever I know, and then just make a table, and I know that I can just keep adding 1, and I'm going to get my final answers. Now let's also do going down the column. So I can start either from the bottom or the top. 12 plus 2 is 14. 11 plus 2 is 13. 10 plus 2 is 12. 9 plus 2 is 11. 8 plus 2 is 10. 7 plus 2 is 9. 6 plus 2 is 8. 5 plus 2 is 7. 4 plus 2 is 6. 3 plus 2 is 5. 2 plus 2 is 4. 1 plus 2 is 3, and 0 plus 2 is 2. So the other thing that we've noticed when I have my numbers written out on this grid is that I've noticed that my numbers, the order doesn't make any difference. So if I have 12 plus 2, which equals 14, that is going to be exactly the same as 2 plus 12. So this, with addition, has the cumulative property, which means that the order doesn't make any difference. So that's one of the nice things about having a table as opposed to just a worksheet, is you can start to see patterns. So now you can see that this is what the table, when it's completely filled out, looks like. And so with this, we can see all kinds of patterns. So as we noticed with our 2's, whenever I have addition, everything is just going to increase by 1. So if you get stuck on what am I supposed to do, how are two numbers supposed to be added together, you can always make a table of what the numbers are that you do know, and just know that everything is going to increase. It's a pattern of increasing, and that the order doesn't make any difference. The next thing that you'll notice is that if you just know the addition from 0 to 9, you can pretty much answer any addition problems. So you'll notice that when we get over here to the 10s, the 10s is just it's a 0 and a 1. So if I have my zeros, this first row, get a thicker pen here. So this row, when I just go up all the way up here to the 9, I'm just counting 0 up to 9 because I was adding this 0, and then I just have put the 1 in front because I'm adding that 1 to nothing. So whatever that 10 was added to, it's just going to put that number in the single digit, and then there's a 1 in the front. And then when I start going to the bigger numbers, like 10 plus 10, I'm going to do the same thing. Once again, I'm starting at 0 and I'm counting upwards. And then my second one, because I'm adding 1, I'm just adding 1 to whatever that is. So these are all just 1 plus 1 in the second. The same thing when it goes to 11. I'm doing this first column on the right is just the same thing as when I was doing my values for my 1's. Those are all the same. And then the same thing, now we're doing the 2's. So with addition, everything is always incremental, and using the tables, you can start to see some patterns. Subtraction is going to work the same way. So let's go ahead and let's do our 9's. So if I wanted to do 9 minus 0, that would be 9. 9 minus 1 is 8. 9 minus 2 is 7. 9 minus 3 is 6. 9 minus 4 is 5. 9 minus 5 is 4. 9 minus 6 is 3. 9 minus 7 is 2. 9 minus 8 is 1. 9 minus 9 is 0. Now we're getting into subtracting a bigger number. 9 minus 10 is going to be a minus 1. 9 minus 11 is a minus 2. 9 minus 12 is a minus 3. So with the subtraction, we notice that our numbers are all going to decrease by 1. And then the subtraction, it does depend on the order. So if I'm going, let's go the other direction. If I take 12 minus 1, 12 minus 9 is going to be 3. 11 minus 9 will be 2. 10 minus 9 will be 1. 9 minus 9 is 0. 8 minus 9 is going to be a minus 1. 7 minus 9 is a minus 2. 6 minus 9 is a minus 3. 5 minus 9 is a minus 4. 4 minus 9 is a minus 5. 3 minus 9 is a minus 6. 2 minus 9 is a minus 7. 1 minus 9 is a minus 8. And 0 minus 9 is a minus 9. So we notice that the order does make a difference on subtraction. But you'll notice that we have a pattern. You can already see a pattern on a table that you wouldn't necessarily see when you are doing just a list of a bunch of problems. So you can see when the subtraction table is all filled out, these they start out positive and then they decrease and then they go in the opposite order with your negatives. So if the first number is bigger than the second number, the number you're subtracting, your answer is going to be positive. If the number is smaller and then you're going to subtract a bigger number, your answer is going to be negative. But you'll also notice that with this whole table, you're just going to decrease everything by 1. And so if you're not quite sure, you can make a table based on what you know and then start building from there to help you figure it out. And just like what we saw with the addition, you really just need to know your 0 through 9, because once you start getting into the bigger numbers, you're just going to start duplicating. So when we look at, so for example, we can look at 12. We start at 0. So if we're looking at this column here, we're going zeros all the way down, so this to the 9. And then look, here we're starting again, 0, 1, 2, and then we just have another digit. So these are all, they're just going to shift by 1, and then once you've gotten to your 9, you're going to start back over at 0, and then you're going to repeat that number sequence. Multiplication works the same way. So let's go ahead and do some multiplication. Let's do our 5s. So 5 times 0 is 0. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. 5 times 6 is 30. 5 times 7 is 35. 5 times 8 is 40. 5 times 9 is 45. 5 times 10 is 50. 5 times 11 is 55. 5 times 12 is 60. Now we can do the same thing, but going in the reverse order. So we've got 12 times 5 is 60. 11 times 5 is 55. And you can start in either direction. So I'm starting from the top going down, but you can also go from the bottom going up. It doesn't really make any difference. 10 times 5 is 50. 9 times 5 is 45. 8 times 5 is 40. 7 times 5 is 35. 6 times 5 is 30. 5 times 5 is 25. 4 times 5 is 20. 3 times 5 is 15. 2 times 5 is 10. 1 times 5 is 5. And 0 times 5 is 0. So once again, like we saw with addition, we see that multiplication also has the commutative property and the order does not make any difference. The other thing that we notice by having these all in a row is that we notice anytime we multiply by an even number, we're going to end up with an even answer. So that's going to help us out when we're solving our problems to identify whether or not we've done it correctly, is whether or not we've got an odd number as our answer or an even number. So here we have a chart with the multiplication all filled out, and we can notice there's a few patterns. So the first thing that we already noticed is that anytime I multiply by an even number, then I'm going to have an even answer. The other thing that I can notice is I can notice a few other patterns. So let's take a look at the 9s. Now, if you'll notice with the 9s, the first digit is always going to be 1 less than whatever I multiplied by. So, for example, here we have 2 times 9. Then that means it's 1 less, which is a 1. And then with the 9s, these all add up. These are always going to add up to 9. So 8 plus 1 is 9. Let's look at another one. So if I have 9 times 9, that's 81. 9 minus 1 is an 8, and 8 plus 1 equals 9. So this is a trick for our multiplications of 9s, and it's a lot easier to see when I have it in a column rather than on a worksheet. Let's look at another one. If we look at the 10s, we notice that whenever I multiply by a 10, it's going to be the number that I multiplied by with a 0 added to the end. So all of these are going to end in a 0 at the end, and I've got a 1 here. So you'll notice that is the same as me taking the zeros in the first column, or the column to the right, and then everything that's on in the ones is been on the first. The 11s are the same as multiplying our 1 and 1. So it's just we've listed this row, this column of 1, and we did that twice. All of these numbers are going to repeat. And then the 12s, we have a 2, and the 2s, that whole row of 2 matches the 2s. So you'll notice there's patterns, and you can see these patterns and relationships when we have them on a table. So just like we saw with addition and subtraction, if you know your multiplication for 0 through 9, know what all of those numbers are, then you should be able to do any type of multiplication problem. So our division tables are really helpful because they allow us to do division, long division, rounding, and the conversion of fractions to decimals. So we know that if we have, so for example, if I'm looking at 8, and if I have 8 divided by 2, which equals 4, that is the same as 8 over 2, the fraction, which is going to be 4. And if I wanted to flip this around, so if I have 8 divided by 4, that's going to be 2 right here. And then if I have 4 divided by 8, so 4 divided by 8, that's the same thing as 4 over 8. That's going to do our long division. Bottom's going to go on the outside. 4 is going to go on the inside. We do our long division. 8 can't go into 4, but 8 can go into 40. 5 times. So that intersection is going to go right here at 0, 5. When you're doing division, with your long division, you're going to have to do rounding. And depending on how many digits after the decimal they want the final answer, it's going to depend on where you do your rounding and what your final answer is going to be. So you'll notice in these two tables, the first table, I have rounded to 4 digits after the decimal, and on the second one I have rounded to just 1 digit after the decimal. So on this table you can start to see the relationship, the patterns, and how they differ based on how many digits after the decimal that you're going to round to. The other thing that you're going to notice are what are the patterns of an individual divisor. So for example, if I'm dividing by 5, I can see that all of these are going to change by an increment of 0.2. So if I'm going to be dividing by 5, if I have an answer divided by 5, I'm going to, if I've done my table, I can quickly identify whether or not I've got a correct answer. The same thing here if I divide by, say, a 6 or a 3, I can see that there are patterns of 0.33 and 0.66. These are going to tell me whether or not I've done my math correctly. The other pattern that you're going to notice with these tables is depending on if the number is bigger or smaller. So if I have something like 12, so if the number on top is bigger, then I would expect to have a whole number in front of my decimal. If the number on top is smaller, I'm going to expect to have a 0 followed by a decimal. And if I'm practicing on my division tables, that's going to help me to clearly see those patterns and to be able to identify whether or not I've set my problem up correctly. So you'll notice, so like if I'm doing, so if I have a problem, let's do one like 11. So if I have 11 divided by 3, let's do this. 11 divided by 3 is going to get round to 3.7. The 11 is bigger than the 3, so I've got that 3, that whole number, and then if I just want it to 1 decimal, then it's going to round up to 7. But if I do the opposite, I do 3 divided by 11, that's just going to be 0.3. So 3 divided by 11 is going to be 0.3 because the top number is smaller than the bottom number. So that's one of the ways that you're going to identify whether or not you've done your division correctly is, do I have a whole number before the decimal or do I have a 0 in front of the decimal? And if you're practicing them on these division tables, you can see those patterns a little bit clearer. So that should give you some good examples of how to use math tables to practice your addition, subtraction, multiplication, and division to help improve your test performance and memory of how these different operators work. You can see the link in the description for a downloadable PDF that includes the math tables shown in this tutorial, as well as some blank grids where you can put any numbers and operators that you want. Remember that in addition to solving for addition, subtraction, multiplication, and division, you can also use these to help you with solving for your fractions, finding common denominators, multiples, and converting fractions to decimals. I hope you have found this video helpful. See the links in the description for additional supports and resources, and be sure to like and subscribe to get the latest videos and resources from CAS Academy. I'll see you at the next video.